How do Alice and Bob explain quantum teleportation? Imagine two friends, Alice and Bob, trying to send a secret message without passing a physical letter. Instead, they use a strange process from the world of quantum physics called quantum teleportation. This process lets them transfer the state of a tiny particle, called a qubit, from Alice to Bob without moving the particle itself. It sounds like science fiction, but it's real and has been tested in labs. The key ingredients are quantum entanglement and classical communication. Alice and Bob start by sharing a pair of entangled qubits. These are special because the state of one instantly relates to the state of the other, no matter how far apart they are. Think of it like a pair of magic gloves that always match each other, even if one is on the moon and the other on Earth. Alice wants to send the state of a third qubit, which holds her message, to Bob. She performs a special measurement called a Bell state measurement on her message qubit and her half of the entangled pair. This measurement combines the two qubits and collapses their states into one of four possible Bell states. When she does this, the original message qubit state is destroyed on her side, respecting the rule that you cannot copy quantum information. Alice then takes the result of her measurement, which is two classical bits of information, and sends it to Bob through regular communication channels like the internet or a phone line. Once Bob receives these two bits, he knows exactly what operation to perform on his entangled qubit. Depending on the bits, he applies one of four possible quantum gates, which are like tiny switches. After this step, Bob's qubit takes on the exact state of Alice's original message qubit. This is why it's called teleportation. The quantum state has moved from Alice to Bob without the particle physically traveling between them. But it's important to note that this process isn't instant. Bob has to wait for Alice's classical message before he can complete the transfer. Also, no matter how strange it sounds, no energy or matter is transferred during this process. Only the information about the quantum state moves. This strange dance of entanglement and measurement is a key part of experimental and emerging science. It shows how quantum physics can do things that seem impossible, like teleporting a particle state across distances. Scientists are working on making this process faster and more reliable, with future technologies that could include ultra-secure communication networks and quantum internet systems. So, Alice and Bob's explanation boils down to this. They use entangled particles, measurements, and classical messages to transfer the exact quantum state from one place to another without moving the particle itself. It's a weird, wonderful example of how quantum mechanics can turn our ideas of communication upside down.